Okay, let's have a quick read of this question. A block 12 kg is pulled in a straight line on a rough horizontal surface by a constant force of magnitude 70 newtons. Assume there is no air resistance acting on the block. So A, the acceleration of the block is 3.3. Find the coefficient friction between the block and the surface. Give your answer to two significant figures. Explain. Right, let's do that first. So let's do a horizontal. Let's get the block. So this, oops, terrible drawing. So this is horizontal block, this is a block, so that has a weight going vertically down, which is 12g. We've got a tension pulling it horizontally of 70 newtons. We've got friction opposing it and normal contact forces here. Okay, so let's do Newton's second law, which is force equals mass times acceleration. So the resultant force here is, this is pulling it, what's going against it is friction, and that will be mass, which is 12 times a acceleration. So okay, let's rearrange this, so make that go there, so that gets 70 minus 12a equals friction. Now we've been told that acceleration is 3.3, so you can do friction therefore will equal 70 minus 12 times 3.3. so the friction is, let's just quickly do this, 12 times 3.3, take that from 70, you will end up with 30.4 newtons. That's the friction. Now we also know what a formula about friction, that friction when it's active, the maximum friction will be mu times Rn. So in this case, friction will equal mu times Rn is 12g. So let's bring that in our equation. So we got friction equals mu 12g, and that will equal this friction 30.4 newtons. So if I want to find mu, therefore mu would equal 30.4 divided by 12g, and that's divided by brackets 12 times 9.8 close bracket. I'm going to get 0.28, sorry, 0.2585 blah blah blah, but I want it to two significant figures, so that will be 0.26. okay, so mu will be 0.26. and second part, explain how and why your answer in part A will change if you assume there is air resistance, that air resistance does act on the block. Well, we've got friction only acting, but if we also got air resistance acting, okay, the overall friction here will be reduced because you got other frictions acting on it, okay, because you got other forces. So that force, that friction now will consist of the friction plus the air resistance, so that will reduce, and if that friction reduces, that means the mu will also reduce. Okay, so that gets smaller, so anything divided by something that is less of a friction, that will be smaller. Therefore explain how and why your answer in part A will change with with air resistance with air resistance, because you've got air resistant, the overall friction with the surface. So with air resistance, the overall friction with surface will be reduced, in which case mu will